The next type of the window functions, ranking functions. They're the functions which return a ranking value for each row in a partition. In practice, they may be used, for example, for simple numeration of a list, rating composition, or selection by pages. The syntax of a ranking function is the following. The function type and obligatory keyword over are specified. The partition by clause is optional for the ranking functions, and in case it's absent, the rows will be ranked within the whole dataset. But the order by clause is required. We'll start getting familiar with the ranking functions by the function row number. It calculates the sequential rows numbers, starting from 1 in the appropriate window section and according to the specified ordering. Let's display the sales amount by the channels for September and October 2000. And now let's rank all rows of the dataset by the sales amount in descending order. The function trunc was applied to the sales amount in order to analyze how the function handles the same values. The function row number generated unique rows numbers, and note that the two rows have the same sales sum value of 600,000, and the function row number returned the different values. These two rows were sorted in a random way. Now let's rank the rows not within the entire dataset, but within a partition by channels. We see that the sales amounts were ranked within each channel. The same sales amounts refer to the same channel, and the ranking function returned the different values. Let's consider more ranking functions, rank and dense rank, and we will learn what is their difference from the row number function. Row number, starting with 1, calculates sequential row numbers, regardless of presence or absence of the repeated values. Rank is a function which returns a rank of each row, and in case of finding the equal values, it returns the same ranks with the omission of the next value. Dense rank function returns the rank of each row as well, but in contrast to the rank function, it returns a rank without omission, the next one. Let's move to an example of using of the rank function. In the current case, we rank rows by the sales amount. In this example, we use the function twice. In the first case, the sorting is in ascending order by default. In the second case, we specify explicitly that the sorting should be done in descending order. By that, the null values should be remained at the end. In the order by clause, in the window definition, it's allowed to use more than one column, likewise with the order by clause in a query. The current example illustrates exactly such a case. We sort the rows by months, and if there are several rows with the same month value, the rows will be also sorted by sales number in descending order. The difference between the functions rank and dense rank is best seen in the example of queries, where both these functions are used. In this example, we rank rows by the sales amount. The function trunc was intentionally applied to the sales sum in order to get several equal values. So we can see that for the equal values of the sales amount, the functions rank and dense rank return the same ranks. Two first rows have the equal sales amount, and correspondingly, ranks of these rows are equal to 1. The differences between these functions can be seen by an example of the third row. The function rank returned the value 3, that is, the function omitted the value 2 since two rows with the rank 1 exist. The function dense rank doesn't omit values in case of equal ranks, and for the third row, it returns the value 2. Let's consider an example of using the rank function along with a dataset division into partitions. So this query returns a report of the sales amount by channels and months. In the report, 2 channels and 4 months are presented. The rank function ranks rows within the partitions, which are created by channels. That is, for each of 2 channels, we rank rows by the sales amount. The ranking within partition will start with 1. We can see in the final dataset that the rows were ranked from 1 to 4 within the first partition. In the 5th row, the function rank again returns 1, since in this row, a new partition starts and the ranking starts from beginning. How you already know, within one query, we can use several window functions, each of which can divide the dataset into different partitions. In this example, we formed 2 columns. First of them ranks rows by sales, within partition by month. That is, 4 partitions are formed for 8th, 9th, 10th, and 11th months. And within each partition, the rows are ranked by the sales amount. The second rank function divides the dataset into partitions by channels. That is, for each of two channels, we rank rows by the sales amount. Let's try to rewrite this example using the alternative syntax. We can declare the named window in the window clause and move the window's definition into this section. Within the window function, you can refer to this window by an alias now. Now the function in the select statement looks more concise. Using of such syntax is justified when there is a great number of window functions in a query with the same window definition. Using of the window clause allows us to avoid multiple duplications of code and makes the query more descriptive. And let's say a few words about the ranking of null values. The ranking functions process such values as equal and assign the same rank to them. While sorting, we can specify both descending and ascending order and the place of the null values in the end or in the beginning. The given example shows us different combinations of sorting and placement of the null values. We can see that the same rank is assigned to the all null values, 1 or 20, depending on the sorting specified within a window function. The next function which we will get acquainted with titles entile. The syntax of this function looks like the syntax of the ranking functions. The main difference of this function is that it takes a parameter as input, which is a number of groups, which dataset will be divided into. Entile is a function which divides the result set into groups by a defined column in such a way in order that the row's number in a group will be as similar as possible. In a given example, we formed 3 columns. They differ only by a parameter, which the function entile takes. In the first case, we divided the dataset of 12 rows into 4 groups. 12 divides perfectly by 4, and as a result we get 4 groups of 3 rows each. In the second case, the function entile divides the same dataset into 5 groups. In the case when the number of rows is not evenly divisible by the number of groups, the entile function places 1 less row to the last groups, then to the first groups. And finally, if an argument of the function entile will more than 1 row's quantity, a number of groups will be equal to the row's quantity, and each group will contain 1 row. This example is illustrated by the last column of the dataset. The next function we will get acquainted with is named cumDist. It calculates the relative position of the specified value in the group and returns a number in the range from 0 to 1. Based on ascending sort order, the cumDist value for row S is the number of rows with values less than or equal to S, divided by the total number of rows n received in the partition or the entire resulting dataset. In the current example, it can be noticed that there are 3 rows with the value 20 or less than 20. Therefore, we got the same value for the second and third rows. This function may be used for finding, for example, 5% of the best-selling goods. Let's consider an example. We see a sales report for July, August, and September 2000 by product categories. The function cumDist divides the dataset into partitions by months. In the result, we got 3 partitions. Values within each partition are sorted in ascending order by the sales amount. Then we divide row's number with a value less than or equal to the current row within each partition by the row's number of the partition. So the value for the first row equals 0.2. For the last row it is 1. Now let's try to solve the following task. You need to create a report which will include 5 best-selling products within each product subcategory. The report should contain only those subcategories by which sales are not less than 20% of sales by product categories. And again, we will divide the solution of this task into 2 stages. Above all, we need to display the following columns: category, subcategory, product identifier, and sales amount by this product. Then we need to use window functions. The column cat sales returns the sales amount for each product category. The column subcat sales returns the sales amount for each product subcategory. We need both these columns for selection of those subcategories by which sales are more than 20% within a category. The last column is formed by the ranking function rank. We sort the products by the sales amount within the product subcategory in order to find top 5 of the best-selling products. On the next stage, we just add two conditions. To begin with, we're only interested in those subcategories which sales make up more than 20% of sales for a product category. We see that one of the subcategories was not included in the final result. The second condition selects only 5 best-selling products within each subcategory. The product with an identifier 115 had a rating of 6, therefore it was not included in the result. The task is solved.